Hello and welcome to Top Linux Tech. In this video, I'm going to show you how to install, configure, and perform some essential maintenance tasks in Arch Linux. I have to point out that this is going to be a very long video, somewhere around 2 hours, and it goes into the details of not only installing Arch, but also covers topics such as configuring basic shell environment settings, installing and managing software, various ways to mount disks and set permissions, configuring the Gnome desktop environment, and performing essential system maintenance tasks. Also, I have provided timestamps for this video so you can easily jump and review it topic by topic. This video is meant to be a complete full guide that will show you how to have a fully working system and desktop environment out of the box. I also have to point out that this video is mostly suitable for those of you who have at least basic understanding of the Linux operating system, and those of you who like to experiment and you have used some beginner-friendly Linux distributions in the past, like Ubuntu for example. If you are totally new to Linux, make sure you first try to reproduce the steps that you see in this video inside a virtual machine, and if you don't have that one installed on your computer, I would recommend that you go with VirtualBox. Now, before we go and dive into the video, I'd like to point out a few things about Arch and why it is my favorite distribution. One reason is because it's built from scratch. Unlike many distros out there that are based on other distros like Ubuntu being based on Debian for example, Arch is quite independent and original in this regard. It is a very lightweight distribution that allows you to build your Linux system almost from scratch by carefully selecting and putting all of the components yourself to make a fully usable system. This is the preferred method for those that know exactly what they want, but also for those that are interested in learning more about Linux, because Arch provides great learning experience for those that want to know more. Another reason is the community and documentation. Arch Linux has a vast user community that is always willing to help, contribute, and give back to its users. And also, the Arch Wiki is a rich documentation library that contains guides and answers to anything related to the operating system. Also, Arch is a rolling release distro that always delivers the latest software available for use. Because of this, it is always up to date with latest fixes and new features, so there is really nothing to worry about too much. And finally, the AUR, or the Arch User Repository, is a collection of software that is compiled, packaged, and maintained by the user community. If there is a package that is not to be found in the official Arch repo, chances are you'll find it here in the AUR. And with all that being said, let's go and begin with this tutorial. The preferred method to install Arch Linux is from a bootable flash drive. All you need to do is prepare a small USB flash drive with minimum size of 1 GB to be used for the installation. In this tutorial, we are going to install Arch Linux in UEFI mode, which is the preferred method for modern computers. First, download the ISO image from one of the official Arch Linux repository servers that is closest to your location and save it to your computer. If you're on Windows, the best tool that I can recommend for flashing USB drives is Rufus. Go ahead and visit rufus.ie and download the USB flash tool. Once the tool is downloaded, simply plug your flash drive in one of the USB ports, start the application, and choose it from the device menu. Then click on Select and click on the Arch ISO image that you have just downloaded. Choose GPT as a partitioning scheme, and finally click on Start. Click OK and wait for the process to finish. Finally, click Close and reboot your computer. If you're using Linux, you can simply achieve this by using the dd command to flash the USB. Execute dd input file equals and then the name of the ISO file that you have just downloaded, and for the output file here, simply specify your USB device name. Keep the block size to 4 megabytes or don't specify block size at all if you have a slow USB flash drive. When you're done, simply boot your computer from the USB. If you're doing this on a virtual machine, simply use the ISO as a bootable media.
Okay, so right after you boot your system with the live installation USB, you'll be presented with this EFI selection menu. So go ahead, select the first option here on the menu, press enter, and wait for a system to boot into the live environment. And we are finally inside the live environment, but before I do anything else, I'm going to choose a bigger font so that you can see the information on the screen better, and you might also want to do the same before installing your new system. So let's use the set font command to change our console fonts. So we type in set font /usr share kbd console fonts, and let's choose Sun 12 by 22. And by the way, there's auto completion enabled for the current shell, so you can just press tab to autocomplete commands. Just like that. And hopefully that's much better and the text is now much easier to read. Now, before we begin with the installation process, we must first verify that we are connected to the internet. In my case, I'm using a virtual machine that's connected via Ethernet, but for those of you who are using wireless, you will have to set up your connection first. In order to do that, we are going to use this nice utility called Wi-Fi menu. So let's type in Wi-Fi-menu and press enter. And immediately you'll be presented with the list of available networks from which you can choose. So choose yours. In my case, this is VL2. Press enter. Let's give it a name, so WLAN 0 is fine. Type in your Wi-Fi password and press enter. And that's it. We should now have connectivity. Keep in mind that this might take a few seconds until the Wi-Fi adapter gets its IP address from the DHCP, and we can verify this by typing in the command ipaddr show. And sure enough, we can see that the WLAN0 interface has been already assigned an IP address. So let's test internet connectivity now by pinging Google. So let's type in ping-c for count for google.com. And there we go. We have successfully established a connection to the internet. And now comes the part where you need to select a server that hosts the Arch installation packages, which is geographically close to your location. This list can be found in the etc/pacman.d directory. There's a file called mirror list, so let's open it. And by the way, I'm using Vim because that's my favorite text editor, but you can use Nano or any other editor you like. So as you can see here from the list, all of the servers are actually available for the system to use. But we don't want that because we want to select only those that are closest to our location. So I'm going to alter this file by using Vim substitution. So I'm going to type in %s for substitute. And I want to substitute everything that says server with hash server. And let's do that globally. So as you can see, I have commented out all of the options, and now I'm free to choose only those that I'm going to use. So in this case, I'm going to select a server that is closest to my location. And that should be this one. So let's uncomment that. And by the way, you can choose from 1 up to 3 servers, for example. In this case, I'm only going to use this server, and this is fine for this demonstration. So when you're done selecting your servers, simply save the file.
And just a quick update here. In this video, I'm not going to show on how to use Vim, but for those of you who are new to Linux, you should use the nano editor instead. So type in nano /etc pacman.d mirror list, and this will open the nano editor. So press Ctrl and \, and then down here where it says search to replace, type in server and replace with #server. Replace this instance. We press A for all instances. And finally, you can select these servers that you plan to use. So uncomment those. And when you're done, simply save the file by pressing Ctrl and X. Save modified buffer, press yes. File name to write, press enter. And that's it.
There we go. And now after we have selected our server, we actually have to refresh our local package database information. So to do that, we need to type in pacman-S YY and press enter. And there we go, we have successfully synchronized the package database. Okay, good. And now we need to prepare our hard disk or SSD for the operating system installation and configure the boot and home partitions. First, I'm going to list all of the available block devices that exist into this system by typing in the command ls-blk and press enter. And as you can see here from this list, we currently only have one disk to work with, and that's VDA. Now, VDA is my virtual disk, but on a real system it's probably going to be SDA, SDB, or maybe SDC, depending on your configuration and number of drives. So let's call the gdisk utility now. Gdisk is a disk partitioning utility, and it's just like fdisk. Maybe you have used that one in the past, but this one, it's specifically made to work with GPT partitions. And since this is a UEFI type of installation, we will use this utility. So let's type in gdisk on /dev/VDA, which is my disk. Okay, so as you can see, the program has already created a new GPT entry into memory. And let's actually create our first partition now, which will be the boot partition. So let's type in N for new and press enter. We'll accept the default number, which is 1. And the first sector will be the beginning of the disk. So let's press enter. And for the last sector, we can either specify the sector number or we can specify the size of the partition. So in this case, we want our boot partition to be at least 500 megabytes in size. So let's type in plus 500 M for megabytes and press enter. Now, the current proposed partition type is 8300, which is the Linux file system, and that's not what we want, so we have to change it into EF00, because that's the code for EFI partitions. And let's press enter. And there we go. We have successfully created our first partition, the boot partition. We can verify the information anytime by typing in P for print and press enter. Next, let's create the second partition now, or the operating system partition. So type N again, press enter. The default number will be 2. And the first sector will be right after the last sector of where the previous partition ends. So press enter here. And for the size, or the last sector, we can specify plus 24 gigabytes, which should be sufficient for most Linux operating systems. So press enter. And we're gonna accept the default type 8300, which is the Linux file system. So press enter. Type P again. Okay. And finally, let's create our home partition, which will contain the user data. Press N again for new. Accept the default number 3. For the first sector, press enter. And for the last sector here, I'm actually going to use all of the remaining disk space available. So I'll press enter. Accept the 8300 file system. Press P to verify. And there we have it. We have created our partitions, and the changes are currently operating in memory. So we'll have to flush the changes to the disk. So to do that, we type W for write, press enter. Do you want to proceed? Yes, enter. And the partition table has been successfully written to the disk. We can verify this by typing in lsblk again to list block devices. And sure enough, we can see that under the VDA, there are 3 partitions created. Okay, and now that we have created our partitions, before we can use them, we'll have to format them with the appropriate file system. To do that, we will use the mkfs command. So let's format our first partition, or the boot partition. So we're going to type in mkfs-t for type, and we are going to use the FAT file system, which is the standard for EFI partitions. And then we are going to say -F space 32, because this is going to be a FAT32 type partition. And we're going to use this on /dev/vda1, which is the boot partition in my case. And there we go. Now we will format the operating system partition. So again, mkfs-t for type. And in this case, my choice is going to be the ext4 file system, which is one of the available file systems that you can use to format Linux partitions. Now, this is just my preference. You can use XFS or any other file system you like. So mkfs-t ext4 on /dev/vda2. And we are going to repeat the same for VDA3, or our home partition. There we go. And now that our partitions have been formatted, we need to mount them within the installation environment inside the mnt folder. This folder will serve as a temporary mount directory that we will use during the initial operating system files extraction process and bootloader setup. So let's list block devices again. And let's mount our operating system partition first. So I'm going to type in mount /dev/vda /vda2 inside the temporary mount folder, which is /mnt. And once this is done, we will now need to create a few more folders inside the operating system partition, which is, by the way, mounted inside /mnt. So next, we will create the boot folder that will serve as a mount point for our boot partition. So let's type in mkdir-p on /mnt/boot/efi. And also, we will create our home folder that will serve as a mount point for our home partition. So again, mkdir/mnt/home. Okay, and let's clear the screen again. And we see here that the operating system partition is mounted under MNT. So let's list the contents of the MNT folder. And we'll see that the operating system partition contains the boot and the home folder. And now we will have to mount the respective partitions on these folders. So let's mount the boot partition first. So mount /dev/vda1 on /mnt boot efi. And let's also mount the home partition. So mount /dev/vda3 inside mnt home. Okay. And let's list block devices again. Okay, everything seems fine, so we can finally proceed with the next step. And the next step is to download and extract the operating system files and the kernel into the operating system partition. For this, we will use the pacstrap command on the mnt folder where our operating system partition is mounted. Now, before we use the pacstrap command to pull the operating system files, you'll have to make a choice which Linux kernel are you going to use. Arch comes with two versions of the kernel. One is the LTS or the long-term support kernel that's proving to be stable, but it is a little bit older. And then there is the latest kernel with built-in latest patches, fixes, and kernel modules. If you want to be on the safe side, then you can use the LTS version. However, if you want the latest and greatest, or if you plan to do gaming or maybe use Steam, then I suggest that you use the current version. Now, I've been using Arch for a very long time, and I always use the latest kernel version, and in my experience, I never had any problems. So let's install the base system now. For this, we will use the pacstrap command on /mnt. So pacstrap/mnt, and we want to install the base system files. We also want to install the Linux kernel and the Linux firmware. Let's also add our text editors, Vim and Nano. And let's also install bash completion. And also, let's add a few more extra packages because you'll end up needing them anyway. So let's install Linux-headers and base devel. Now, if you want to go with the LTS version of the kernel, you will have to type in here linux-lts-headers and linux-lts. But in this case, we are going to go with the latest version of the kernel. So this should be fine. And let's press enter. And everything seems okay so far. We have successfully downloaded the operating system files onto the OS partition, and now we will have to tell the system where to find its partitions during the startup phase. So basically, we'll have to supply the operating system with the fstab file, which tells the system where to find its own partitions. For this purpose, we have this nice cool utility called gen fstab. So let's use it. So we type gen fstab dash capital U for unique identifiers on /mnt. And we can see that all three partitions are now listed properly with their unique identifiers as mount points, but we are not done yet because we need to write this file inside the operating system partition. So let's repeat the last command, and here we'll add > /mnt /etc/fstab. Okay, that should be good. So let's verify that the file has been successfully written. So let's do cat on /mnt etc fstab. And there we go. We have successfully generated the fstab file. Okay, and now it's time to finally switch inside our actual Arch installation and resume the process from there. To switch to our new system, we will use the arch chroot command. So arch chroot on /mnt. And there we go. We are now inside our new operating system environment, and let's install the bootloader so we can boot our system later. So for this, we can use the Arch package manager to do that, which is pacman, by the way. So pacman -S for synchronize, and we will need to install the following packages. So we will need grub, the bootloader. We will also need EFI boot mgr, and then we will need EFI var. We will also need network manager. That one we will need later. And finally, there is one important and very specific package that you must have installed on your system. And that is the package that's actually the microcode for your CPU architecture. So if you are on an Intel system, you'll need to install the Intel ucode package, or if you are on an AMD system, you will need to install the AMD ucode package. This package needs to be installed so that the grub bootloader can use it during the boot phase. Otherwise, you might have problems later on while using the system. In my case, I'm on an Intel system, so I will need Intel-ucode. Press enter. Yes to confirm. And once this is complete, we can now install the grub bootloader to the disk. So the command to do this is grub-install on /dev VDA in my case. And that's it. The bootloader has been installed to the disk, so no problems there. And finally, we will finish the grub installation by writing its settings into the grub config file. Now, before I write the grub config file, I'm going to alter the configuration specifically to my needs. This step is completely optional. You don't have to do it because it's not that important, but you're welcome to try and use these modifications as well. So I'm going to type in vim on /etc default grub. I'm going to open the file for editing. So first thing first, I'd like to change the grub timeout period to be 2 seconds instead of 5. And down here where it says grub cmd line Linux default, I'm actually going to erase this quiet option. And then I'm going to change the grub GFX mode to my monitor's native resolution, which is 1920 by 1080 pixels. And I'll save the file. Okay, so now that we have made these changes, we can write the grub config file. And the command to do that is grub-mkconfig-o on /boot/grub/grub.cfg and press enter. And as you can see, the grub config file has been successfully written to the disk, and also the microcode package for the CPU has been included. So let's now enable the Network Manager service that will allow us to have network connectivity when we boot into our operating system for the first time. So the command to do that is systemctl enable Network Manager. And you'll have to type in Network Manager with capital N and capital M. Press enter. That looks good. And finally, let's change the root account's password. So here we type in passwd and press enter. Type in your password and make sure you type in a strong and secure password. So let's exit the chroot environment now. Type exit. And we are back inside the live installation environment. And from here, we will have to unmount all partitions that we used during the installation phase. So first, we will unmount the boot partition, and the command to do that is umount /mnt/boot/EFI. And then we'll do the same with the home partition. umount/mnt/home. And finally, we unmount the MNT partition. or the operating system partition. And there we go. We are now ready to reboot and start our installed operating system for the first time. So let's type reboot and press enter. And if everything went well, you should be greeted by the grub bootloader screen, and there we go. The Arch installation is now complete. We are now ready to continue installing all necessary software, drivers, and the graphical user environment. So let's log in to our system for the first time. So let's type in root and give the password that we have just assigned previously. And let's also change the console fonts again. So let's go with setFont /usr share kbd console fonts sun 12 by 22. There we go. Let's clear the screen. Okay, now for those of you who are using wireless, you will have to connect to an existing Wi-Fi network. We did this earlier for the live installation environment, but now since we are in our newly installed system, we'll have to do it again. So let's list the network interfaces in our system by issuing the command networkctl list. And from this list, you can see your WLAN network's adapter name. So go ahead, take a note of that, and then type nmtui to access the Network Manager text user interface. And here choose the first option, then go to Add, choose Wi-Fi, give the profile a name. So I will keep this simple and just name it Wi-Fi. And down here, type in your device name. In my case, this is going to be WLP2S0U4. And for the SSID, simply type in your wireless network name. The mode is going to be client. For the security, I'm using WPA2 personal, and you're probably using the same, so let's go with that. Then finally type in your Wi-Fi password. And finally choose OK. Select back and then quit. And now let's actually examine the network connections and see if our Wi-Fi network is active. So let's type in nmcli connection show. And sure enough, we can see that the Wi-Fi network is now active. And let's ping Google again to make sure we have network connectivity. So ping -c4 google.com, and there we go. We have successfully established a connection to the internet. Now, in order to make things more clear on the screen, and instead of me using the console fonts, I have actually logged in via SSH into my virtual machine, so we can resume the installation from here. Now, the first thing before installing the software is to give our system a name, set the proper time zone and the system locale.
So let's give a name to our system now. To do this, we will edit the file inside the etc and it's called hostname. So I will simply name my system test VM and save the file. Next, we also want to assign the loopback address for local name resolution, so we edit the file inside etc and it's called hosts. And here I will simply assign a loopback address to localhost, and also I will assign a loopback address to my system's name, which is testvm, and save the file. Let's now change our time zone, or set the proper time zone. So to do this, we will use the command timedate_ctl set-time zone, and here simply input your own time zone. So in my case, this is going to be Europe/Skopje. And if you are wondering where's the list of all of the available zone files, they can be found inside usr share zone info. Let's also enable the network time protocol service, which will synchronize our system clock against internet time servers. So let's type in timedate_ctl set-ntp, and let's set this to true. And to verify that everything is set correctly, we type in timedate_ctl status. And here we can see the time zone that we have just activated. We can see that the system clock is now synchronized and the NTP service is also active. Next, we set up our system locale. So let's open the file inside etc and it's called locale.gen. Basically, setting up the system locale will enable programs on your computer to correctly display time, date, and monetary regional values, among other things. So here in this list, all you have to do is simply uncomment the ones that you need. So in my case, I need English_US, and I also need MK for Macedonian. And when you're done choosing your locale, simply save this file. And we also want to set the system-wide primary locale. So let's create a new file called locale.conf. And this goes into /etc as well. So we create a new file here. And here we insert the variable lang equals n_us dot utf-8. And by the way, here you will have to specify your own preferred locale. In my case, this is going to be English. And this file will also get auto-populated with extra values by your desktop environment later. So let's save the file. And let's issue the command locale-gen to generate our new settings. And there we go.
Okay, let's actually create our swap file now. Basically, if you have a system that is low on system memory, then you should definitely set up a swap file and you should set the size according to your needs. But if you have more than enough system RAM, then swap might not be required. However, it is still recommended to create at least a small swap file because there are still some system processes that might need it just in case, especially if you're going to use hibernation. So let's first switch into the root directory. And here let's create an empty file called swap file. And now we need to make this file equivalent to the size of the virtual RAM that we want. So I'm going to inflate this file with zeros and make it 1 gigabyte in size. So to do that, I'm going to use dd. So dd input file equals /dev/0, and the output file will be this swap file that we just created, and the block size will be 1 megabyte, and the count will be 1000. So basically this will make the file 1000 megabytes in size or 1 gigabyte. Press enter. And there we go. Let's verify that everything went correctly. And here we see our swap file. However, the permissions are insecure, so we need to change them. So we use the command chmod and give the permission of 600 on swap file. There we go. And now we will need to convert this empty file into an actual swap file. So we use the command mk swap on swap file, and this creates the swap file. And if you want to immediately use this swap file, then we use the command swap on swap file. And if we type free-m, we will see that the swap file is created and currently in use. So far so good, but if we want to make this change permanent, and if we want to have the swap file to be loaded automatically every time when the operating system starts, we will have to assign it as an entry inside the fstab file. So let's make modifications to the fstab. So I will use vim as editor to do this. So vim on /etc fstab. And here we add another line. So for the file system, we'll say /swap file, because this file is located inside the root file system. And for the directory, well, actually there's none. For the type, we specify swap. For the options, we specify SW. And for the dump and the pass, we assign the value of 0. And that's it. We simply save this file. And now we need to reboot our system. So let's type in reboot and press enter. Okay, so now that you have restarted your system and logged back in, we're going to make some general environment modifications that will reflect across every user in the system. In this case, we are using the bash shell, and we want to customize few things that will apply to every new user account that we create in the system.
This step is completely optional, but in my case, I'd like to use a few extra color options and some other environment fixed variables, like the default editor, for example. So I'm going to switch inside the etc scale directory now. Keep in mind that the contents of this directory will always get copied inside the user's home folder after you create the account. So here we are specifically interested in the .bashrc file, which is responsible for our local bash environment settings. So let's open it right now. So first, what I would like to specify here is the environment variable for my text editor. And since that is Vim, I'm going to say here export editor equals Vim. And by the way, you should specify your own default editor in this file. And I would also like to specify a few more aliases here. For example, I would like to have an alias for the grep filter, and I also want the grep filter to have color output. And let's duplicate this and do the same for egrep and fgrep as well. And also, I would like to have an extended color support through dir colors. So here I'm going to write a tiny little shell script that will allow me to do that. So here I'm going to say that if the dir colors settings file does not exist inside the user's home directory, and by the way, this applies to every user, then I would like that to be created by printing out the dir colors database inside the home folder of every user. And also, if the dir colors binary exists into the system, and it does by default in every Arch system, then we actually want the dir colors settings to be applied immediately into the user's shell environment. So let's save the file now. Let's test if everything works well now. And by the way, you will need to copy all of these files from the scale directory into the home folder of the root account. But keep in mind that these files will be copied into the home folders of every new user account that you create automatically. So this is an exception. Let's copy everything from this folder into the home folder of the root account. And let's check if the files have been copied. And yes, they have. And now let's quickly log out and log back in to check if everything works correctly. So let's type exit to log out and log back in. Let's list the contents of the root directory. And yes, we have color output now. And probably the aliases will work as well. And yes, they do. So everything seems fine.
And we see that the dear colors file has been automatically created, so we are all set. So let's now create a standard user account that we will use as the default in our system. To create a new user in the system, we use the command user add and then dash dash create dash home, and then we specify the desired username. So in my case, I'm just gonna say TLT. Press enter, and immediately you'll have to change the user's password because there's none. So let's use the command passwd on the username to give it a password. Press enter, make sure you type in secure password, and there we go. And now let's make this user a member to the following common groups. To do that, we use the command usermod -a for append, and then g for group, and then we add the user to the following groups: wheel, users, storage, power, LP, ADM, and optical. And these are, by the way, the most commonly used groups. And then we specify the username, so TLT. Now, if we want to verify to which groups the user already belongs, we can simply type in ID and then the username, press enter, and here we can see all of the groups that the user has been assigned to. Next, let's actually modify the sudoers file so that every user who belongs to the wheel group can request super user privilege escalation. And by the way, if you haven't specified your default text editor in the bashrc file like we did earlier, you will have to temporarily enable it in your current environment by typing in the command export editor equals and then your favorites editor name. That might be Nano or Vim or whatever. Otherwise, let's use the command vi sudo to edit the sudoers file. So let's type in vi sudo and press enter. And here we simply scroll down and uncomment the following line that says %wheel all equals all in brackets and then all. When you're done, then simply save the file. And that's it. We have successfully created a standard user account, and we can now proceed to installing the necessary software. So let's install Xorg now. As you know, Xorg is the display server used on Unix operating systems that allows you to run a graphical environment. And to install it, we can either use the xorg-server or the full Xorg package. I always go with the full package because it's not like it's going to cost us a lot of disk space anyway. So to install it, we use the pacman package manager, and we type in pacman-S and then xorg and press enter. Now we accept the default suggestion here, so we press enter and proceed with installation, yes. And we wait for the components to be installed into the system. And now that Xorg has been installed, let's add some common font packages. So let's type pacman-S and Let's type in ttf dash and we press tab twice. So here I'm going to choose the following ones: ttf deja vu, ttf droid, ttf hack, and let's also add ttf font awesome. And there's also another package, otf font awesome. Let's also add ttf lato, ttf liberation, ttf linux libertine, ttf open sans. Let's also add ttf roboto, and finally ttf ubuntu font family, and press enter. Proceed with the installation, yes. And there we go, we have added several font packages. By the way, I always install these as the default, but you may choose a different font packages if you like. Now, there are a few extra font options that you might also want to enable system-wide for the font rendering. This step is completely optional, and out of the box you will have a fine font rendering, since the FreeType library has different licensing options regarding the rendering these days. But you might also want to enable some specific font configuration anyway. To do this, we'll symbolically link the font options that we need from the etc fonts conf.avail into the etc fonts conf.d directory. So let's first navigate into the etc fonts conf.d directory, and let's list the available options that we have right now. Let's also list the available options that we can use from the conf avail directory. And basically what I would like to use here is subpixel RGB, LCD filter default, and no bitmaps, because I don't want to use the old bitmaps fonts. So let's link the needed options right now. So let's type in ln for link -s for symbolic, and we want etc fonts conf.avail, and I want 10 dash subpixel RGB into the conf.d directory. I also want 11 LCD filter default, and finally I also want the no bitmaps. Let's see if we actually have all the needed settings, and yes, we have enabled the subpixel, the LCD filter default, and the no bitmaps configuration. And finally, let's enable some FreeType font settings to be used in our user environment by default. So we edit the file inside etc profile.d freetype2.sh. And here you can see all of the available settings that you can use. So Let's uncomment the bottom line here, and I will simply use the version 40 because that is the default. And I'll simply save the file. And there we go. We have made changes to our font configuration. Now let's install video card drivers. I assume that you are aware of the video card that you are using inside your computer, but if you are not aware of the model and the type, simply use the command lspci to find out and look for the line where it says VGA compatible controller or something similar. Now, here I have compiled a list of video card driver packages that you need to install depending on the video card type. So, for example, if you have Intel, then you would install the xf86-video-intel, libgl, Mesa, and optionally Vulkan-Intel package. And so on. Now, keep in mind that these driver packages are intended for the newer generation of video cards. So if you have an older video card, you should always consult with the ArchWiki webpage to find out the corresponding driver package that you need. Now in my case, this is a virtual machine with limited video card support. So in this case, I will not be installing any video card drivers. But let's pretend that I have a new NVIDIA card. So I would need to install the following packages. So here I would say pacman-S NVIDIA, NVIDIA-settings, and NVIDIA-utils. And I would also need to install the Mesa package. Okay, so time to install our desktop environment. Now, when it comes to graphical desktop environments, there are plenty to choose from. The most popular on the list are Gnome, KDE, XFCE, Mate, Budgie, the surprisingly newer and interesting Deepin desktop environment, and maybe a few others. There's plenty of them to choose from. However, in this tutorial we will be installing the Gnome desktop environment. Now I like to install Gnome with all of the available extras that comes with. So we will need the Gnome, Gnome Extra, and the GDM package. So let's use pacman to install Gnome, Gnome-extra, and also GDM, and press enter. Accept all of the default selections. And proceed with the installation. So type in Y. Now sit back and relax because this might take a while since we are downloading about nearly 3 gigabytes of software. Okay, so the installation is finally done. So let's now enable the Gnome Display Manager service by typing in the command systemctl enable GDM. There we go. And also, as a final touch before we boot into our graphical desktop environment, let's purge the local package cache of downloaded software by using pacman -S cc, and we confirm both selections. And by the way, sometimes you might receive an error while you are downloading software. So if that happens, it's most likely because your local package database information is outdated, and you will have to simply refresh the database by issuing the command pacman -S YY, and that should fix the problem. So let's finally reboot our computer and log in into the desktop environment. So, if you have installed everything correctly, you will be greeted by the login screen. So let's click the user account that we created earlier during the installation phase. And now, before we actually log in, I would like to advise you to choose whether you want to use the old X11 or the newer Wayland session type. Keep in mind that the Wayland display protocol is intended to replace X11, but it is still under development and some features might not be working correctly, such as screencasting, for example. So if you click down here in the lower right corner of the screen, you will get to choose between the session types. So Gnome on Xorg will give you X11, and Gnome will give you the Wayland session. And here, for the Gnome Classic, this will actually give you the classic shell, and I think that one lacks some 3D acceleration features. So you shouldn't really use this one unless it is absolutely necessary for you to do so. And I would also like to point out that if you have an Intel or an AMD card, you will probably get to choose between the two sessions. However, for those of you that are using NVIDIA card, you may or you may not get to choose Wayland at all. Regardless if you choose the GNOME option, it will still get you the X11. So let's type in the password and press enter to log in into our desktop environment. And now that we have successfully logged in into our desktop environment, let's first customize a few settings. So here I will choose the settings option from the upper right corner of the screen, which will open the GNOME settings panel, and from here we can set all of the system settings that we need. There is also the GNOME Tweaks tool that gives us additional settings, and more on that later. So, for example, we can change the background. And let's now actually change some system settings that you would most likely want to configure. For example, here in the search option, you can configure the various indexing options available. I personally don't like constant indexing to be active on my system, so I always turn this option off. Next, under the Privacy tab, you can choose the different options for the camera, microphone, the file history, and the screen locking. For the power options here, you can configure the settings related to power savings and suspend. And also, very important, for those of you that need multi-language support, keyboard layouts, and other input methods, you can select them here under the region and language. So let's add another input source. Here we click the plus sign, and then we click on the three dots, and immediately the language that we defined earlier in the locale settings will appear. So let's choose that. And also, let's choose the formats for the dates and currencies display options. You would probably want them to be displayed into your own language. So we can define those settings here as well. So I'll choose mine and click done. And finally, after you have defined all of the settings, click the restart button. You have to relog into the system for all of the settings can take effect. And there we go. Those are the most basic settings that you would like to configure immediately after the installation. Now, let's also review the Gnome Tweak tool. So, pretty much by default and out of the box, the Gnome desktop environment is heavily focused on workspace management and much less on classic desktop features, and by comparison, it might actually look poor when compared to other desktop environments out there. The positive aspects of Gnome are the speed and the easy, snappy workspace management, which gives you fluid and smooth workflow if you are someone that needs to work with multiple workspaces and windows. Now, regardless of this classic desktop lack of features, Gnome can be further customized by installing various shell extensions, and the app to manage this is called Gnome Tweak Tool. So, if we press the super key on the keyboard or the Windows key, the Activities window will open. And here we have the search bar, the Applications dash, and the Applications menu. So we can either look for the tool in this menu, or we can simply type in the name. So let's type in Tweaks, open that, and here we have the Tweaks tool. So let's enable some commonly used settings in the Tweak tool, and then we will install some additional extensions from the internet. The most commonly used options here are the Appearance tab, from where you can choose your theme, icons, and sound settings. I usually like to go with the dark theme, so let's enable that. And here in the Extensions tab, let's actually enable a few extensions. So here, I'd like to have the Places status indicator, for example, which will give us an additional menu here in the top bar. And as you can see, this provides shortcuts to the most commonly used folders. And for example, you might also want to enable the removable drive menu. And it will give you also quick access to the mounted removable drives. You might also want to enable the user themes if you plan to install additional themes from the internet. And workspace indicator, for example. This will show you the current workspace that you are in. So let's go to the Fonts tab, and here everything looks good, but we can choose the subpixel for LCD screens. This relates to the font rendering that we previously enabled during the installation phase. For the Keyboard and Mouse tab, here you can customize additional settings. The defaults are fine in my case. You can also add your startup favorite applications here. And for the top bar, you can customize additional settings like the weekday, for example. And in the window title bars, this is actually very important and one of the most commonly used features. So it enables to have the maximize and the minimize buttons for the application windows. And here for the windows and the workspaces, the defaults are pretty much fine, but you can further customize according to your needs. So let's actually now install a few more extensions from the internet that are actually quite useful. So let's open up the terminal real quick. Let's make this window bigger. And let's first quickly refresh our local package information database. So sudo pacman -S YY. And let's install Firefox. And let's now install a package that will enable us to install extensions through our web browser. So here we can install the Chrome-Gnome shell. And by the way, this one will work with most browsers. So let's install that. Let's exit. Let's open up Firefox. Let's actually add it to favorites. And let's search for Gnome shell extensions. And we obviously need to install the browser extension so that we have this functionality. So let's go to that. Refresh the page. And now let's add a few more extensions that are really useful. Let's add Open Weather. This will display weather information on the top bar. So let's add that. Click Install. And there we have it. Let's also look for dash to dock. And this is a useful dock for the Gnome shell. It allows you to move the application dashboard anywhere on the screen. So let's install that as well. Now let's search for a very useful extension, and it's called Clipboard Indicator. And basically it will add a clipboard indicator to the top panel, and it will cache clipboard history. Very useful, definitely a must want to have. And if you have multiple sound devices in your system, you would also like to have the sound input and output device chooser. It will also extend the functionality of the top menu here. And finally, let's look for the app indicators. So this is the one, case status notifier item slash app indicator support. So let's install that one as well. And basically, this will enable the application tray icons in the top panel. I'm not sure why this functionality was removed from Gnome, but I'm glad that we can still have it through this extension. And for this extension to work, we also need to install a very specific package. So let's open up the terminal again. And let's install lib app indicator-gtk3. This is the one that you need. Now let's open up the Gnome Tweak tool again. And under the extensions tab, you will find all of the new extensions that you have just installed via the internet. And if you click here on the cog icon, you can customize each and every one of them. And in case if that doesn't work for you, you can always customize them through the extensions app. It will basically do the same job. So let's position the dashed dock to the bottom of the screen. And there we go. Now, these extensions will give you the most of the needed desktop functionality, so make sure you configure them according to your needs. And here we are. I have finished some customizations to my Gnome desktop environment, and as you can see, this is now the end product, a minimalistic but very functional and fast desktop environment. I simply love the performance of Gnome compared to other desktops. Now, the one good thing about Arch is that not only it has a vast repository of software, but also it has the Arch user repository, or the AUR, from where you can install almost any software that you need. And it is completely maintained by its users. Keep in mind that the AUR is not the official Arch repository, and you should pay attention when installing software from other sources. In other words, you have to trust or inspect the packages that you download, and that is if you want to be very cautious. In my opinion, in 99% of the cases, you shouldn't worry about it too much because all of the repositories are always under the supervision of the users themselves. Let me show you how you can add an unofficial repo and install something from the AUR database. So basically, when you search for software in the central Arch repository, you may not always find what you're looking for. For example, let's search for Skype. And we see that the package does not exist in the central Arch repository. And by the way, let me just quickly here enable the color output for pacman. So sudo vim /etc pacman.conf. And this will give us a nice color output so that we can see the package information much better on the screen. So let's search again, pacman-ss for search. And there we have it. We have color output now. So as you saw, we couldn't find the package that we were looking for. Let's open up the Arch website instead and look for the package there. Let's click this link, which will take us to the central repository. And let's search for Skype here. And of course, the package does not exist because pacman package manager pulls its information from this database. So let's try the AUR link now. And let's search again for Skype. And there we have it. Skype for Linux stable binary. This is the one that we want. Let's click on that. And you will have to copy this link where it says git clone URL. So let's copy that. And let's go back to our terminal now. I would recommend that you create a special folder where you will download the packages from the AUR database. Let's create it right now. So make dir AUR, and this is inside my home folder where I want to keep my AUR packages. So let's switch to that one right now. And let's actually check if we have Git installed, because you'll have to download the packages with the Git program. So pacman-q, capital Q, for query. And let's see if I have Git on my computer. And yes, I do. So the command is git clone, and then simply paste the link. There we go. Now if we list the contents, we will see that the AUR has downloaded all of the necessary files from which we'll have to build the Skype binary. So let's switch inside. And here we only have to use the command make pkg for make package -si. So make pkg-si. And this will automatically pull the software and all of the dependencies from the source, and then the system will compile it into a working program, and we're done. Now, the make program requires CPU resources, so we actually want to make sure we give it all of the available CPU cores for this operation. So before we install it, let's actually quickly modify the make pkg file. So let's go sudo vim /etc/make pkg.conf. Type in your password, and down here where it says make flags equals -j2, and by the way, this option tells the system to use 2 of the available CPU cores, so we don't want that. So let's uncomment this option, and let's replace the number 2 with the variable nproc. And this will allow us to use all of the CPU cores available. So let's save the file. And now let's finally execute the make package command. So make pkg-si, press enter, confirm yes. You may also get a password prompt, so you should enter your password anytime when it is required to build the packages. So this is going to probably take a while because the system is compiling the binary from source. And depending on the size of the program, the waiting time will be different. And now we proceed with the installation. You can see that the total installation size will be about 267 megabytes. So type yes. And there we go. The Skype program is now installed into our machine. Let's switch to another workspace. And let's see if the app is here. And there we have it. Let's actually add this to our favorites. And there we go. That is how you actually install a package manually from the AUR database. So, the only downside to using the AUR is that you will have to manually check and update any package that you have installed into the system. The Arch Package Manager pacman has no information about the AUR packages on your system, and therefore it cannot be used to update them. And for this reason, if manual updates are a trouble for you, then let me show you how you can automate this process by installing an AUR helper. So let's search for AUR helpers. Let's go to the wiki and let's type in AUR help. And from this page, we can find that actually there are several of AUR helpers available. And you can see the detailed information about each of them on this list. So let's pick one. Let's actually go with Yay for this demonstration. So again, we will have to clone this git URL. So let's copy that. Go back and do the same for the Yay helper. So git clone, and let's paste the address. Let's switch inside and let's do make pkg-si. Proceed with installation. And there we go. We have installed the Yay AUR helper. So now let's install another AUR package, but this time we will use the Yay program. And the good thing about Yay is that it is also a wrapper for pacman, and it also supports the same commands that you can use with pacman. Also keep in mind that when it comes to updating AUR packages, you will have to use Yay instead of pacman. We will discuss this in more detail later when we will talk about system maintenance. So let's actually install another package now. Let's install Viber, a chat and messaging program most popular on mobile devices. So let's search for Viber here in the AUR database. And as we can see, it exists in the AUR. There it is. Let's switch back to our terminal. And now let's do Yay dash capital S, just like pacman. And let's install Viber. Well, let's first search for it. And there we have it. So let's now install it. And just press enter to accept the defaults here. Proceed with the installation, yes. And finally, it is done. And let's actually check to see if the program has installed correctly. So let's type in Viber, and there it is. So we have automated the installation of software from the AUR database. Now there is one other alternative. There are other repositories that exist and contain precompiled packages found in the AUR. In order to use these repositories, you will have to add them to the pacman.conf file. These repositories may offer you a way around AUR helpers, such as Yay, and even though they are carefully maintained, these reside on private servers and nobody can guarantee their safety, and you should use them at your own risk. So let's configure a few unofficial repos now. Let's Google unofficial arch repos. And here we get the list from the Arch wiki. So let's actually choose few from this list. For example, let's go with the Endantai AUR. And this repo is signed, so we will also have to obtain and locally sign the corresponding PGP key, and the instructions are on the screen. Let's quickly grab the keys. And let's paste them into the terminal. And there we go. And let's now open the pacman.conf file. So sudo vim /etc pacman.conf. And down here at the bottom, let's add the repository. And let's also add another one. Let's choose this one, Heracura. Now for this one, no key is required. So let's just copy and paste it in here. Save the file. And finally, let's refresh the local package database information. So sudo pacman-S YY. And we can see here on the list that the two repositories have been added. And let's now search for a package that we can install. Let's, for example, search for the Vivaldi browser. So pacman dash capital S small s Vivaldi. And as you can see here from the list, the Vivaldi browser is found in both repos that we have just added. So sometimes there might be conflicting packages, meaning one repo can have an older version of the package, and this might create conflict. In this case, you would have to explicitly choose which one to install by providing the repository name / the package name. So let's install Vivaldi now. And let's also install the ffmpeg codecs for the Vivaldi browser. Let's exit from here. Let's close Firefox. And there we go. We now have configured the system to use unofficial packages, and it is up to you to choose which one of these three alternatives you would like to use when installing packages that are not found in the central official repositories. Okay, now let's go over managing mount points for other disks or block devices that you may have installed into your system. There are several methods of how we can accomplish this. For example, you can have automatic disk mounting by manually specifying the mount points into the fstab file, or you can mount them on demand with a single click through the file manager. Let's first install a few more packages that are required for mounting types of file systems such as NTFS or ISO file systems directly from user space. So let's here install NTFS-3G and fuse ISO. And also let's include gpartadd, which is a nice desktop application for managing disk partitions. And if you haven't used it before, it might actually be useful to you in the future. So let's install that. Let's open up the file manager here. And as you can see, I have already added another disk in my system and labeled it as media. Now when I left click on the disk, it immediately prompts me to enter my super user password in order to mount the disk. This may seem fine, but you would probably want this to happen automatically and save you the trouble of having to enter your password every time, unless you have some specific security concerns, of course. I'll show you how to mount the disk without password and on demand later by modifying the system policy that is responsible for mounting file systems in user space. Let's first add an automatic mount point for our disk inside the fstab file. You can mount the disk by simply specifying the mount point, such as VDB1 for example, or by its unique identifier. Mounting by unique identifiers is a lot more convenient approach because it always refers to a specific block device and not virtual references such as these. Now, these references are randomly generated for each disk that is installed into the system. And for example, if you are swapping drives inside your machine, or maybe you move other disks from other machine, this may become a problem, and then maybe your mount points will be invalid because they will no longer refer to the same disk. Now, to list all of the block devices by their unique identifiers, instead of using the command lsblk, in this case, we will use the command blkid. So sudo blkid. So as you can see, in this case, my VDB1 partition has the following unique identifier. So let's copy that and let's import this into the fstab file. So let's add a new entry down here. And let's add a few comments for our own personal reference. So maybe here we can say my media disk. And let's now add the unique identifier. So we type UUID equals, and then we simply paste the value. And that's the value for a file system. And here for the directory, we need to specify where exactly in the file system we want this disk to be mounted. So I want to mount this disk into the /mnt/media, for example. And here for the file system, I'm going to specify ext4 because the disk is formatted with the ext4 file system. And by the way, you can specify any file system here. So if, for example, you have a disk which is formatted with the NTFS file system, and then in that case, you would say NTFS-3G here. And here for the options, let's go with the default options. So we type in defaults. And by the way, the defaults are suitable in most cases. However, they still won't allow a non-privileged user to mount the disk. So let's actually override a few of the default settings by specifying them with comma. So comma, and let's add the user option here, which will allow any user to mount and unmount the disk manually. And in case if we want to also run executables file from this file system, we can also say comma exec here. And for the dump option, let's give the value of 0. This is not something that you need to be concerned with right now. And for the pass, we assign the option 2 usually. So the possible values are 0, 1, and 2, and they all relate to the file system error checking during system startup. So 0 means no file system check, 1 means which file system gets checked first, and 2 means which file system gets checked last. So, for example, the operating system partition or the root file system is always the one that will be checked first, as you can see from this example. And for all other additional disks, these values can be either 0 or 2. So let's save the file now. And the mount point that we specified in the fstab file currently does not exist. So before we mount the disk, we actually need to create the directory. So let's go sudo nkdir on /mnt and media. And let's now switch inside the mnt directory. So cd/mnt, and let's list the contents. And there we have it. We have created the folder, and now we can simply mount the disk. So To do that, we can do it by the directory name or by the block device name. So I can say something like mount /dev /vdb1, or simply, if it's easier, we can say something like mount /mnt media. And there we go. We have mounted the disk. So even though we have mounted the disk, we still need to change the permissions so that we can have full access. So if we list the contents now, we will see that the permissions currently default to root for both the username and the group name. And if we want to give our user or a group of users read and write access, then we will simply have to change the ownership of this directory. To do that, we can use the command sudo chown -R for recursive, because there may be some other subdirectories within this directory, and we want the ownership to be applied on those as well. And now here we need to specify the desired username to which we will give these permissions. So in my case, this is going to be tlt : and now for the group name, let's actually use the users group. And finally, we specify the directory name. And now, if we do directory listing again, we can see that the TLT user has full read, write, and execute access, and anybody who belongs to this group, to the users group, will only have read and execute permissions. And for all else outside of that, they'll get read and execute as well. Now, if you want to give everyone in the users group also full access, we can simply change the permissions to 775. So sudo chmod -R for recursive, 775 on media. And let's do the listing again. And now we can see that both the username and the group have full read, write, and execute permissions. And let's try to create a folder and maybe an empty text file. So mkdir test, and let's create a text file. And there we go. We have now read and write access. And in most cases, it will probably be just you, yourself, on your computer. So let's actually change the ownership to only this user account. So sudo chown -R, our username, and the group name will be the same, on media, and there we have it. Let's actually restart the system now, and the disk should be automatically mounted when we log back in. So let's open up the file manager now. Let's go to other locations, computer, MNT, media, and there we have it. The disk is now mounted automatically. Now let me also show you the other way of mounting disks on demand and without any password from the file manager. For this, you will need to have a policy file inside the /etc polkit-1 rules.d directory. But first, let's actually unmount the drive now. And let's remove the entry from the etc fstab file. So I'm simply going to comment out this line. And let's restart the computer one more time. Okay, so let's quickly navigate to my documents folder. And here is the file that you need to have. And I have provided this file for you, and it is in the video description down below. So when you get it, you will simply have to copy it inside the rules.d directory as super user or root. So let's actually do that now. Okay. And once the file is in place, you will be able to mount and unmount block devices with a single click from the file manager, just like that, and they will be conveniently displayed in the Other Locations tab. So from here, you will see all of the block devices, and you can easily mount and unmount them with a single click. So mounting through the file manager will actually mount them inside the run media your username directory. Let me show you. Let's switch into the /run/media. And here we see our user. So let's switch to this directory. And now media is mounted in this location. And these are the very essential basics that you need to know for mounting disks from fstab, the file manager, and assigning the basic permissions. Welcome to the final part of this video. Now we will talk about keeping your system always up to date, clean, and optimized. Previously, we talked about how to install software with pacman, yay, and through the AUR. So now let's go over managing, removing, and cleaning up unused packages. Okay, let's start with pacman. As you are aware, the command pacman-S will install a package on your system, but if you add the small s flag, it will actually search for the package that you need. If you add the I flag instead, it will give you the detailed information about the package you are searching for. If you want to query your local package information and get a list of all packages currently installed on your system, you can do that with the command pacman-Q. And this will give you the list. You can also look for a specific package that exists on your system by typing in pacman-Q and then simply type the package name you're looking for. And this will list the package name and the version number. You can also get an extended information about the same package by adding the S flag, and this will provide a brief package description. And also, you can get the full and the detailed information about the package by simply specifying the I flag here. In case if you're wondering how many packages exist on your system, you can simply query your local package database by using the command pacman-Q and then pipe that through wc for word count -l for lines. And here we can see that we currently have 936 packages installed in our system, and we can accomplish the same with yay -P for print and then S for statistics. And this will also give us the information. It will also give some other useful information about the 10 biggest packages that exist on our system. Finally, for a quick overview of all available flags or options that you can use with the pacman command, type in pacman-help, and this will list all of the options. For more help and detailed explanation, you should use the manual page for pacman, which you can access by using the command man pacman. And basically, this will give you the manual page from where you can find detailed explanation about every option. Now, what if you want to remove an installed package from your system? You can simply use pacman-R for remove and then the package name. And you will have to do this with superuser privileges. So type in sudo pacman-R and then the package that you want to remove. Now, doing it this way will only remove the package itself and not its dependencies. So I will answer no here. To remove the package and all of its dependencies, just append the S flag to the pacman-R command. And this will completely remove the package in the same way as it was installed. The additional S flag that we specified stands for removing packages recursively. So I will type in yes here. And this will completely remove the package from the system and all of its dependencies. For maintenance purposes, you can always check if there are any unneeded orphaned packages which exist on your system and that you can safely remove just to keep your system clean. To find out if such packages exist on your system, simply use the command pacman-Q for local query, and then T for unneeded, D for dependencies, and Q for quiet operation. And here you will see a list of packages that are no longer needed on your system. We can safely remove these packages by using the command sudo pacman-R for remove, S for recursive operation, and then simply specify the previous query command as a shell variable. And this will remove these unneeded and unused packages on your system. And in case if you're using an AUR helper such as yay and you want to accomplish the same, you can simply type yay -Y and then C. For those of you coming from other Linux distributions, you can find the pacman Rosetta page, which is part of the Arch wiki that will show you a list of package management corresponding commands from other distributions compared to Arch. For example, the apt install command in Debian or Ubuntu is equivalent to pacman-S, and so on. Now, If you are not using any AUR helper and you prefer to manually install AUR packages by downloading and compiling them, in this case, you will also have to manually update them as well. So all you have to do is switch inside the AUR package folder of the application that you want to update. For example, I want to check if there are updates for the Skype app that I've previously installed. So I'll switch to that. And then to check for updates, we have to run the command git pull. And if you get something like already up to date, like in this case, then there is nothing else to do. However, if you get something like new files added or updated, then you will need to run the make pkg-si command again to download the new version, and make sure that you manually delete the old cached package installers, like these, for example. They will simply take up your space. And if you ever want to remove a package that you have installed through the AUR, you can simply do that with pacman. To update all packages to their latest versions, or simply to install system updates, use the command sudo pacman -syu. And if you have an AUR helper, such as yay, simply use that one instead. So sudo yay-syu. And this will update everything, including the packages that you have installed through yay. So let's update our system now. And after installing the updates, simply restart your computer. By the way, running system updates or installing software on your computer will eventually create a large pool of cached packages which grows in size over time. And to keep your system clean and to always have the maximum disk space available, you should purge this cache during system maintenance. If you want to find out how large is the cache of downloaded packages, you can use the command du for disk usage -hs on /var/cache/pacman. And here we can see that the current cache of downloaded packages is almost 400 megabytes in size. So we can clean this cache by either using pacman or the AUR helper if you have that one installed on your system. So we would say something like sudo pacman-SCC or yay-SCC. And this will remove all package cache from the system. And if we simply repeat the command again, we will see that now the cached information only takes 76 kilobytes. Finally, regarding system updates, it is generally recommended that you run them only once a week, and let this also be your maintenance window. And this is all of the essential information that you need to know in order to manage packages and updates on your Arch system. Okay, let's talk about cleaning system log files now. In Arch Linux, the default logging is performed via journald which is part of systemd. It is a system service that collects and stores log data and other information about your system. Using the command journalctl will list the current log that occurs within the system. And for example, if we specify the -b option, it will give us the logging information that occurred during boot time. And also, if we specify the -xe option, it will give us the extended information, including error messages coming from services if there are any. Now, we will not get into the detail on how to manage journald in this video. We will save that for another time, but instead I will show you how to clean system logs, because over time they will grow and take up a lot of space if they are not maintained properly. First, if we want to check how much space is currently used by journald logs, we can execute the command du for disk usage -hs for statistics on /var log journal. And here we see that currently the logs take 873 megabytes of disk space. To clean the logs, first we must archive them so they are no longer relevant for the system. And to do this, we execute the command journalctl --rotate, and we will have to do it with super user privileges. And this will rotate or archive the log information. And now that we have backed up the logs, we can finally clean them by executing sudo journalctl --vacuum -time equals, and let's actually clear everything from the beginning of time up until the last second. So I will specify 1s here and press enter. And there we go. We have freed 856 megabytes of archived journals. Now, you may also want to automate this process, so in this case you need to edit the file journald.conf, which can be found inside /etc systemd folder. And down here where it says system max use, let's say something like 500 megabytes, and simply save the file. And then once the logs reach 500 megabytes in size, they will be automatically cleaned. And the system will be limited to only 500 megabytes on each journal log rotation. Let's now restart this service by executing the command sudo systemctl restart systemd -journald. And now if we examine the service by saying systemctl status systemd journald, we will actually see that the limit that we have imposed on journald is now active. If you need more information, simply read section 5 of the manual on journald.conf. So you can execute the command man5 journald.conf, and this will provide all the detailed information that you need about maintaining your log size. And this is how you perform configuration and maintenance on system logs in Arch. For the end of this video, let's talk about how to optimize your SSD drive performance by enabling automated trim function. As a general recommendation, it is always advised that you keep the trim function enabled in your operating system, and many operating systems, including various Linux distros, do this automatically. In Arch, you will need to enable the service if you want to have automatic trim, because over time, as you write information to your SSD, it will slow down because these drives, unlike ordinary mechanical drives, write and erase the information in a very different way. The trim function will force the SSD to resynchronize and schedule clearing function for unneeded blocks before new information can be written. Let's now enable periodic SSD trim in Arch by enabling the fstrim service. So here we execute the command sudo systemctl enable fstrim.timer and fstrim.service. And next, we simply start the service, and there we go. Finally, let's check that the service is active. And it is. That is all you need to do, and this service will automatically run once every week for all of your mounted SSDs. You can still force manual trim anytime by executing the command sudo fstrim-a for all and v for verbose. And this is all you need to do for enabling the trim function. This is the end of this video, and I'd like to thank you for watching. I hope the video was informative for you, and if you enjoyed it, please comment, like, share, and subscribe.